So in this video, I want to talk about the average value of a function over an interval. And I want to start off with this problem right here. Say we have the temperature in Lynchburg. Temperature is going to be measured in degrees Fahrenheit over a 1 hour period. So starting at little t equals 0 and going to little t equals 1, given by this formula. So the temperature at a particular time between 0 and 1 is 60 plus 10t squared. Now, ultimately, what I want to do is find the average temperature in Lynchburg during this 1 hour period. But en route, I want to take a look at the temperature at time 0, the temperature at time 1, so the temperature at the beginning of the 1 hour and the temperature at the end of the 1 hour. And I also want to sketch a graph of temperature versus time. So go ahead and pause the video, copy down the question so you have it in your notes. I'm going to assume you've done that, copied the problem down into your notes. And let's start with part A. Find the temperature at time 0 and the temperature at time 1. Well, there's very little to do here. The temperature at time 0 is going to be 60 plus 10 times 0 squared. 60 plus 0 is 60. This is in degrees Fahrenheit. That's a very pleasant temperature. And the temperature 1 hour later, temperature at time 1, is 60 plus 10 times 1 squared. That's going to be 60 plus 10, or 70, again, degrees Fahrenheit. Again, we're still thinking about part C. Is the average temperature over this 1 hour period, is all you do take the temperature at the beginning of the 1 hour period and the temperature at the end of the 1 hour period and average them? Take, add 60 and 70 and divide by 2 to get 65. Let's do part B. So part B says sketch temperature versus time. So all we have here is a, parabola stretched vertically by a factor of 10 and shifted up 60 units. So between 0 and 1, I'm going to put so here's my time axis. Here's t equals 0. Here's t equals 1, 1 hour later. So we're going from 0 to 1. At 1/2, we'd be 30 minutes after we started. And I'll put 60 right here. And I'll put 70 right here. And I know that at time 0, I'm at 60 degrees. At time 1, I'm at 70 degrees. Let me just dot in a horizontal line here. There we go. I'll dot in a horizontal line here. And 65, of course, is right in the middle. So this is temperature in degrees Fahrenheit. This is time in hours. Now, because the shape of the curve, you've graphed things much more complicated than this. This is just a parabola. That's not like the temperature steadily rises linearly from, it doesn't rise as a straight line from 60 to 70. It actually is shaped like a parabola. And 65 is, again, right in the middle, close to the middle as I can draw it. So again, I ask you, does it make sense that the average temperature in Lynchburg over this 1 hour period is just the average of the temperature at the beginning and the end? I'm hoping that right away your natural inclination looking at this picture is no. So this is a graph of t of t. And of course we have a formula for this if we wanted, 60 plus 10t squared. So I don't think most of you looking at this picture would say that the average temperature in Lynchburg over this 1 hour period was exactly halfway between the temperature at the beginning and the temperature at the end. And assuming that's your inclination, my next question is it closer, is it below 65? Is it closer to 60? Or is it above 65? Is it closer to 70? And again, hopefully looking at this picture, most of you would say that the average temperature in Lynchburg over this 1 hour period is actually below 65 because the temperature spends most of its time below 65 and only a little bit above 65. I hope that is what you're thinking naturally. So if you're going to find the average value of a function over an interval, it can't be as simple as taking the value of the function at the beginning of the interval and the value of the function at the end of the interval and just averaging them. So I do need to let you know how to find the average value of a function on an interval. You may have some intuitive idea already just looking at this, but the average value of a function f on an interval, say x equals a to x equals b. Here we're using little t as our independent variable, but if we have x on the horizontal axis, it's just 1 over b minus a. B minus a is just the length of that interval times the integral between a and b of f of x dx. In other words, you just take the area under the curve between a and b and you divide by the length of the interval. Hopefully that makes intuitive sense, or at least seems plausible. But we will take this as the definition of the average value of a function on the interval. So in this particular problem, we're just going to go ahead and use this definition. We need a space on the board over here. Let me get rid of part A, B, and C over here. You have these in your notes. We've already solved part A, which was easy. We solved part B, which was almost as easy. And part C, now that we have this, I think we can do this fairly easily. So the average temperature in Lynchburg over this 1 hour period is going to be 1 over 1 minus 0, the length of the interval. The integral from 0 to 1 of, capital T of t, so in other words, 60 plus 10t squared dt. And again, this you can interpret as the area underneath the curve above the horizontal axis, which is technically way down here. I drew it right here, but 60, 70, you'd have to go all the way down to 0. So it's the area under that curve divided by the length of the curve, divided by the length of the interval. So let's go ahead and do this. 1 over 1 minus 0, that's just 1 over 1. So that's 1 times, now we're going to take the antiderivative. So antiderivative of 60 is 60t. We're using t as our independent variable. The antiderivative of t squared would be 1/3 t cubed, so we have 10/3 t cubed. And we're going between t equals 0 and t equals 1. We're going between t equals 0 and t equals 1. So if you plug t equals 1 in here, you end up with, so this is 1 times, I'm not even going to bother with a 1 anymore. This is 60 times 1 plus 10/3 times 1 plus 10/3 minus 60 times 0 plus 10/3 times 0. And so what we have here is 180 plus 10/3, 190. Again, if you don't like fractions, don't bother with fractions. We do have units. The units are degrees Fahrenheit. And so this is going to be about 63.3 repeating, if you like, 63.3 thereabouts degrees Fahrenheit. And again, it is below 65. So remember, when you want the average value of a function on a whole interval, please, I ask you to remember this because in the pressure of the moment, it's easy to forget. Don't just take the value of the function at the beginning of the interval and the value of the function at the end of the interval and average the two. Go ahead, take the integral over the interval and take multiply by 1 over the length of the interval. In other words, divide by the length of the interval. If you prefer to write it like that, in terms of dividing, we could write the integral from a to b of f of x dx divided by b minus a. It means exactly the same as what we just wrote right there.